that transformation W equals 1 by Z maps a circle in Z plane to a circle in W plane or to a straight line if the circle in the Z plane pass through origin. It is asked in the question that if we have a transformation W equals 1 by Z and if the input given is a circle which lies in the Z plane, we have to prove that the output of this particular circle will be another circle if the considered input circle does not pass through origin. In particular, if the considered circle is passing through origin, then the output displayed by the transformation W equals 1 by Z will be a straight line lying in the W plane. Let us look at the proof. We have the general equation of a circle in the Z plane given by x square plus y square plus 2gx plus 2fy plus c equals 0. When we consider the transformation W equals 1 by Z, where W equals u plus iv and z equals x plus iy, we have the equation u plus iv equals 1 by x plus iy, which can also be written as x plus iy equals 1 by u plus iv. When we just bring x plus iy as numerator to the LHS and u plus iy is taken as denominator to the RHS. Now, here if we multiply both numerator and denominator using the conjugate of this expression, we have u plus iv in the denominator gets multiplied by u minus iv, and the denominator we have terms of the form a plus b and a minus b, which becomes a square minus b square. So, in the denominator we obtain u square minus I square v square. Since I square can be replaced by minus 1, we obtain the denominator as u square plus v square. In the numerator, we have just the expression u minus iv. Now we separate real and imaginary parts in the RHS. We have the real part u by u square plus v square and the imaginary part is given by minus v by u square plus v square. Now we will equate real and imaginary parts on both LHS and RHS, which will give us x, the real part in the LHS, equals u by u square plus v square, which is the real part in the RHS. Similarly, y, which is the imaginary part in the LHS, equals minus v by u square plus v square, which is the imaginary part in the RHS. Since we are looking for the outputs or the images of the circle in the Z plane, we will replace x and y in the general equation of the circle lying in the Z plane using the expressions for x and y which we have obtained in terms of u and v. Therefore, everywhere x appears, we will replace it by u by u square plus v square, and wherever y appears in the general equation of the circle lying in the Z plane, we will replace it by minus v upon u square plus v square. Thus, this general equation of circle transforms to this expression, and you can see that these two terms are having common denominators u square plus v square the whole square. So we can combine these two terms. Therefore, we have u square plus v square upon u square plus v square the whole square, and the other terms, this term and this term also have common denominators, so they can be grouped, which give us the expression 2gu minus 2fb upon u square plus v square. And we are left out with a constant c in the LHS. The RHS is 0, which comes from the general equation itself. Here, after simplification, this expression becomes 1 by u square plus v square. Now, if we multiply both sides of this equation using u square plus v square in the numerators, we obtain 1 plus 2gu minus 2fv plus c into u square plus v square equals 0. And we know u square plus v square when multiplied with 0 in the RHS will become 0 itself. Now we will consider two cases, c equals 0 and c not equals 0. Suppose c equals 0 in this equation, it would mean that the circle is passing through origin, because c is the distance from the origin. If c equals 0, it means that the circle is at 0 distance from origin, or circle passed through origin. When you are considering the input circle with c equals 0, the circle is actually passing through origin. If you give c equals 0 here, you obtain the images 1 plus 2gu minus 2fv, which is of the form ax plus by plus k equals 0, which is the equation of straight line. Here we know u and v are the variables, just like we have x and y are the variables in the general equation of straight line ax plus by plus c equals 0. So the conclusion is that when the input circle considered is a circle passing through origin, the image obtained is a straight line. The second case is that c naught equals 0. When you consider the situation c naught equals 0 in this equation, it means that the input circle is not passing through origin, or it's at a distance c from origin. Here also we will consider c naught equals 0. Then the corresponding image of this circle with c naught equals 0 will be another circle which is of this equation. This equation is actually equation of a circle itself which lie in the UV plane or the W plane.